Greetings of the day, dear students. In this video, we are going to discuss about the ideal versus practical diode. What are the differences between the ideal diode and a practical diode? We will see its circuit symbol and what is its equivalent representation if it is an ideal diode, and also we will discuss its equivalent VI graph if it is practical diode, and also we will discuss the differences between the ideal and practical diode. Right now, dear students, please observe, if it is ideal diode, right, it's nothing but a two terminal device, but it permits only in the unidirectional conduction. How do you understand that? For example, if it allows the current flow from A to B, but it does not allow the current flow from B to A. But if you observe the resistor, right, it allows the current flow from A to B, and also the current can be flown from B to A. It's a bidirectional device. But whereas if the diode is perfect and ideal, it allows the conduction only in one direction. It's unidirectional. This point is very, very important. Moreover, it acts like a perfect insulator during reverse biased condition, right? When the diode is reverse biased, there should not be any conduction. Perfect insulator. How do you understand that? If it is a perfect insulator, resistance must be infinite, and the moment the resistance is infinite, there should not be any amount of current flowing. I will be zero, right? Similarly, if it is a ideal diode, during forward bias condition, it acts like a perfect conductor during this is wrong. During it acts like a perfect conductor during forward bias. So it acts like a perfect conductor. How do you understand that? If it is a perfect conductor, the resistance must be 0 ohms, right? The voltage drop across that will be 0 volt, and the current flowing will be high. The current flowing will be high. So this is the diode representation: anode positive, right? Cathode negative, and this is the arrowhead. Now under forward bias condition, the resistance is 0 ohms, right? The voltage drop will be 0 volt. That is what you can observe here. Even though there is no voltage, there is some magnitude of current. The drop across diode is not there. During forward bias condition, you can observe the current on the y-axis, and during reverse bias condition, it is almost like an open switch, right? The resistance offered is equals to infinite ohm. At that stage, once it is kept open, the current must be equal to 0 amps if it is a ideal diode, right? Now during the reverse bias condition, you used to get a graph like this, current on negative x-axis, right? Now, but whereas with respect to the practical diode, actual diode, what happens is it does not behave like a perfect conductor when it is forward bias, or it does not behave like a perfect insulator when it is reverse bias. So how do you understand that? It is not behaving like a perfect conductor. That means its resistance will not be made perfectly zero when it is forward biased, right? So it is something can be represented like this if it is a practical diode. Similarly, here you can observe anode is positive, cathode is negative. Anode, cathode we are having. Now under forward bias condition, you will have this some voltage V0, and because of the internal resistance of the diode, and the internal resistance of the diode, let it be some RF. Because of that RF, as the during conduction mode, as the current flows through the diode, there will be some voltage drop across the diode. Now that drop in the forward bias condition, now the the voltage formula for voltage V equals to IR. Already the current flowing through the diode, let it be IF, and the resistance in the forward biased mode be RF. Now there will be a drop of IF into RF. Amount of voltage will be wasted or will be dropped across the diode in forward biased mode, right? Now V0 indicates the potential barrier. If you recollect the basics, for silicon, that potential barrier will be zero point 0.7 volt. If it is germanium diode, the barrier potential is zero point 0.3 volt. So if we can write like this, Vf will be equal to zero point 0.7 plus IFRF for silicon diode, Vf equal to 0.3 plus IFRF for germanium diode. Now if you observe the VI characteristics, VI graph is something somewhere here up to 0.3 volts, it will there won't be any conduction. The moment it crosses its barrier potential, if it is for germanium, there will be a sudden rise in the current. It comes into the conduction mode. If it is ideal or perfect diode, uh, at zero potential itself, it should come into the conduction, but that is not the case for practical diode, right? The moment it has crossed the barrier potential, it comes into the conduction. If it is silicon, we can observe it somewhere at 0.7 volts up to that voltage it will bear. From 0.7 volts onwards, there will be the conduction in the diode, right? So indirectly, for practical purpose, diode can be considered as an open switch when it is reverse bias, and because of the value of reverse resistance is so high, right? So if you observe some differences between the ideal diode and practical diode, we can observe that ideal diode acts as a perfect conductor. If it acts like a perfect conductor, resistance must be how much? Resistance must be equal to 0 ohm, right? If the resistance itself is 0, then the magnitude of current will be high. Now, if it is ideal diode under reverse biased condition, there should not be current drawn. So, what do you understand that under reverse biased condition, the resistance must be infinite ohms. So, under it offers infinite resistance when it is reverse bias, and it will have zero cut-in voltage. And also, there won't be any voltage drop across the junction when it is forward bias. There won't be any internal resistance. So there won't be any voltage drop due to the flow of current through the diode. But whereas if it is in the practical case, the diode cannot be acted as perfect conductor or as perfect insulator, perfect conductor or perfect insulator. Now practically the diode will draw some very little amount of current when it is reverse bias, and also it will offer some high resistance, but it is not infinite resistance. It offers some resistance, but the magnitude will be high but not infinite, right? When it is reverse bias, and also it will have some very low cut-in voltage, and there will be some amount of voltage drop across the diode when it is forward bias due to the internal resistance offered by the diode, some RF forward bias resistance. Because of the current flow through the diode, there will be some voltage drop in the diode, right? So dear students, like this you have to highlight the points when it is asked, differentiate between the ideal diode or practical diode. Like this, these are the points, important points to be highlighted, right? Right. So dear students, I request you once again to share this application with as many students as possible, with your friends and classmates in your same college and different colleges, which will be helpful to them. And also at the same time, as we are at the starting stage of developing this app, right, it will also be helpful for me also. I hope you will cooperate in this aspect, right? Once you complete this subject, the moment juniors comes to your college, then also please share. Of course, that is the case with after 1 year or 6 months, right? But you please also share this, you just guide your juniors also, those who are having this subject, to use this application or download this app, right? Thank you.